In addition to using built-in classes, we can define our own classes and then create instances of those classes to build new types of objects. A class describes the behavior of its instances. Let's say we want to represent bank accounts, and we want to bundle together the information related to a bank account, such as having an account balance and an account holder, with behavior related to a bank account, such as depositing money into it and withdrawing money out. The way this works is that all bank accounts need to have a balance and a holder, which means that it needs to be up to the account class, which we will define on the next slide, to create these attributes to each newly created account instance. This line uses the account class, which we're about to define, but let's assume we've defined it already, to create a new account instance. So here's the class. I call it like it's a function, and that creates a new instance, A. This instance, A, has as its holder John. So if I look up its holder attribute, I see John. How do I know it's called holder? Well, that's part of the class definition that we're about to look at. But the abstraction is that I can access the holder and I can access the balance of any account using dot expressions where holder and balance are called attributes of the A object, which is an instance of the account class. All bank accounts should share a withdraw method and a deposit method, meaning that they behave in the same way. They might have different balances and different holders, but what it means to deposit into a bank account is the same regardless of which bank account it is. Here we invoke the deposit method on A and deposit 15 into it, and that leaves us with a remaining balance of 15 since it was 0 before. After we withdraw 10, that withdraws 10 of the balance, leaving us with 5. So both the deposit and the withdraw method change the balance and return whatever it is after the change. Now we can see that the balance has been updated, so withdrawing and depositing use the balance, which is an attribute, in order to keep all of these things in sync. This is an example of a local state. What do I mean by local? I mean this balance is particular to the A object. It's not something that I could refer to without a dot expression. A method can have arbitrarily complicated behavior associated with it. You can write any function you want. So maybe it's the case that when you withdraw, it first checks to make sure that you have enough money, and if not, then it returns the string insufficient funds and does not update the balance. Deposit and withdraw are methods, and methods are defined within the class of the object, in this case the account class. In order to achieve this behavior, we have to write a fair amount of code. So I'm just going to walk through all of it now so that you can see it, and then we'll talk about the details of why it is the way it is. Methods are functions defined in a class statement. So a class statement starts with the keyword class, then you have to name the class, then you have to define what happens when you create a new instance of this class, which is the first line here. And you do that using the special method name init, which is always written this way, even with these underscores, because that's the function that automatically gets called when you create a new account. Here we refer to this new account as self and assign attributes to it, balance and holder, where balance is always set to 0 and holder is assigned to whatever gets passed in, which gets a name from the function definition. And notice that the name of the attribute can be different than the name used inside of this init function. So now we've provided attributes to the object, but we also need to provide behavior. And so we define methods. Methods look like functions, but they're defined within a class. And here, the deposit method takes 2 arguments. The first one is self, and self is the instance of the account class on which deposit was invoked when I write a dot expression using deposit. So notice that I call deposit on only 1 argument, but I define it in terms of 2, so that I have access to all the attributes of the account that I'm depositing into. It's as if A is assigned to self. Now we can look at the code within deposit. It changes the balance attribute by looking up the balance attribute and adding the amount, and then returns the balance attribute. The return statement is why we see some output when we write a.deposit. If we didn't have a return statement, that would be okay. It would just return none and could still change the balance. The withdraw method is a little bit more complicated. It takes in an account called self and a number called amount, checks to see if the amount is greater than self.balance. Notice that each time I want to refer to balance, I have to use a dot expression because it's an attribute. I can return whatever I want, and I can also update attributes of self or return them. This definition of an account enables us to use an account like this. And that's how you create a new type of object.